Shall we start? We are briefly introduced. I request you to be silent. Inheritance, so out of all the relationships that you have seen between classes, inheritance is one of the most prominent and the most important one. It is widely used in industry, especially for the projects that have large teams. The biggest advantage that inheritance gives you is reusability. So think about this. In 2018, I joined IIT Delhi as a postdoctoral research. And my guide, my advisor, he was working on a project which was related to developing a social network kind of a telephonic based service for people in rural areas so that they could record messages for each other, but in a language which is not English or Hindi, in their own rural languages. So apart from the development of the platform, I can you spread out a bit. कैसे बैठे हो आप लोग अच्छे से बैठो ना बहुत स्पेस है फील एट होम Okay, so there was a lot of data that we were analyzing. Then I was new to the team, so what they gave was they gave me some code which was written by the previous students, and I was expected to understand that code and then build upon that code. So I spent 2 days trying to understand that code, but it was really difficult. A code written in one flow, although it had functions, but no comments, so that you could understand what a function is doing. I kept on understanding that code for 2 days without any fruitful results. So I finally did the entire code on my own from scratch and then worked on that project. Now, although this approach, it can work well in academia where you have smaller projects, smaller teams. But if you talk about in industry, you got really big groups, right? Big teams, big projects. So you cannot afford to do that. Everyone start writing their own code instead of using something which someone else has already written. So that is what inheritance offers you, allows you to extend the code which is previously written by some other person. So here's an example. So let's say whenever you look at some two people who look very similar to each other, has it occurred to you that they are in some way related to each other? They are probably siblings or they are, let's say, parent children, or they have some kind of relationship between them, is it? Or do you believe in the theory of 7 lookalikes and visions of doppelgangers and so although that can happen, but that is very rare. So there's actually a study that showed that the chances to find someone who look exactly like you in this entire world is actually 1 in 1 trillion. So you can find people who are similar to you, but somebody who is same to you, very difficult to find. So similar to how you have similar people, you have similar classes. We can see an example here. So you have two classes, person and employee. Can you see some relation between them? Hmm? There are some attributes which are common, right? So if you look at this person class, it has string, age, it has name, age, walk and talk. So basically 4 functions if I represent that. And if you look at the class employee, it has all those 4 attributes. In addition, it has something more. Right? So you can say that employee is sort of surrounding the class person in that sense. So what you can do is you see 4 attributes which are common. Now there are two ways of coding it. One way is go ahead, write a class person with 4 members. Go ahead, write a different class employee with 8 members. But if you are doing it that way, you are not taking benefit of the redundancy in the code. And there is some code which is redundant. So what you can rather do is take this class person, define these 4 members, and have this class employee inherited from the class person. So whatever is a part of person automatically becomes a part of the employee and you can directly use it. So that is one kind of inheritance. This is called simple inheritance. So it is just one level. So you can actually extend this and take it across multiple levels. You can form a chain of inheritance. As an example, look at this. So can you tell which class will inherit which one here? Right? So employee can inherit person. Everything that is a part of person is a part of employee also. Or in other words, you can say an employee is a person. So that's the best way to see whether there is an inheritance relationship, whether the is a relationship holds. Similarly, your manager is an employee and whatever is a part of employee is a part of manager. So you can do it across multiple levels. So this is called multi-level inheritance. You can do one more thing. Okay, what about this case? This is slightly different. So you have a class person which has some attributes, name, age, walk and talk. If you look at class employee, it has all the attributes and methods that person has plus some extra ones. So I could. So employee goes something like this. And if you look at class student, so between student and employee, there are certain things common, but they are not a perfect superset or subset of each other, right? So what you can do, whatever is in person is in student also. So your student class is something like this. Right? So whatever is in person is in employee, whatever is in person that is in student, but there is no such relationship between employee and student. So both of these classes can inherit your class person. So this is called hierarchical inheritance. You have a class person and so you are essentially building a hierarchy here. You can inherit employee from here or you can inherit student from here. Okay, now can you think about how the inheritance will look like, let's say, for someone who is a working student? Here it becomes a bit complex. So, working student means a class, somebody who is an employee as well as student. So, what can we do here? Right, so the class working student probably inherits both employee and student. So, you can, let's say, we decide we'll have a class working student here and it inherits from class employee and class student also. So that is something called multiple inheritance, but for some reasons it's not allowed in Java. So you cannot do something like that. So anytime you look at a inheritance hierarchy or an inheritance tree, one class can have only one parent. So one class having multiple parents is not allowed. So we'll see why it's not allowed, and then if it's not allowed, what's the way to do it? That we'll see in the future sessions. So you can go on and build trees of inheritance. Let's say something like this. So do not worry about the term abstract here. We'll see it later. But you can see here is a big inheritance tree where organism is at the top. So it is combining all the ideas. It has multiple levels. It also has a hierarchy. So you can call it hybrid inheritance. It's just a name for it. But the point is, if you look at every class here, every class has exactly one parent, right? One parent can have multiple children. Right? So you can go on and build inheritance trees like this. So in a while we'll look at the code for this. There are certain things that we should address while coding inheritance. Before that, let's have a small quiz. So I'm going to put the link on the chat window. So go ahead and attempt it. It is something we just now discussed, very simple, plain, straightforward. It will take you 1 minute to do it actually. The easiest question is the one that needs to write your name and number. Done? Can you raise your hands if done? Okay. Okay, so the first one, you see multiple levels here. So multi-level inheritance. This one. So this is a hierarchy here, but this is what? Multi-level, right? So it has both. So you can say it's a hybrid inheritance. Okay. Okay, so let's go ahead and see how we can start coding this idea. I'm going to create a file, let's say inheritance Java. Okay. So what I'm going to do is, let's say, create a class father and let's have attribute here. Right. So as an example, let's say something a father might have, let's say a bike. So let's say father has a bike and let's give it some name. Honda. So that's all your class father has. Creating your main class here. Okay, any problem with this code? Is something wrong? Hmm? Anything wrong? Bike is from another class. Bike is from? No, it's a string, right? bike is the name of an instance variable. Its data type is string. Right? If you write here bike equals to Honda, then that's a problem. Then you should have another class which is named as bike. So we are keeping it string for now. Right? So works well, right? Not a problem. Right. So let's have one more class here. Let's say kid. And let's say this class is empty for now, has nothing. And I'll just change this to kid. Okay. Any problem now? And what's the problem? There is no bike in the class kid. Right. So if you run this code, you see that error. Let's just quickly see that. Right. So you get this error that I cannot find this symbol bike in the class kid. So what you can probably do is extends father. What does that mean? That means although kid doesn't have a bike of his own, he's inheriting one from his father and now he can use it. Right. So and now the same code works. So is it an example of inheritance? Right, technically, yes, it's an example of inheritance. You have a class father, you have a kid. Kid is extending father, but it's actually really a very bad example of inheritance. Do you see why? You can use inheritance like this. There is nothing syntactically wrong with this program. It works, it executes. But conceptually, do you see something wrong here? Kid is not a father, right? That relationship is not established here. Tomorrow you can add some more attributes to father, and do you think the kid is going to inherit each and everything of that? Kid is going to have all those attributes. Father might have salary. So do you think kid should also have salary? Father might have a wife. Kid might not be married. So doesn't make sense, right? Kid is not a father. So be really careful in how you use inheritance. So here are some other bad examples of how you can use it in a bad way. Right? So you cannot say kid extends father just because he wants to use the bike. Similarly, you cannot say dog extends human. Let's say you have a class human which has an attribute called height. Now you want another class dog, which also has an attribute called height, doesn't mean that the dog will start inheriting human, right? Just for those shared attributes. Bird extends aeroplane, again conceptually wrong. But you can say they both fly. So aeroplane flies. So there's a fly function in my aeroplane class. I'll create a class bird which extends it. No. So it should be conceptually correct. Otherwise, it's a bad design. Okay. So let's try to make it conceptually correct here. So what can be a good class that can extend this father class? Okay. Grandfather is a father. He should be. Okay, we can take grandfather or anything else. Mother. So we can just put a vowel property instead of. So your comment reminds me of one more thing. So what do we do here? You see, you are saying that the father had a bike and kid now wants to use that bike. But we said inheritance is not the relationship you use here. So what do you do? Let's say if kid wants to use father's bike, right? You can use some other kind of relationship here, which we studied. So as an example, association is a good example here. What you can do is instead of kid extending father, you can have a father object here, which tells you who is the father of this kid. Then you can use F's bike here, right? So association is a better relationship here as compared to inheritance. Okay, so coming back, you have a grandfather. Let's say a rich father. Now, what does that mean? Rich father is also a father. He's going to have a bike. He's rich, but he can have some more things. right, as compared to what a father has. So let's say he has a private jet of his own, creating an attribute called private jet here. Let's say he owns a jet. Now, you can create an object of type rich father, and you will have access to both the attributes f dot bike and f dot private jet, right? So although rich father doesn't have an attribute bike here, he is inheriting it from father. Okay. What if, let's say, remove rich from here? Do you think still this code will work well? Or is there some problem? There's a problem, right? So we are creating an object of type father. Father has a bike, but father doesn't have a private jet. Right? So that gives you a problem here. So it's only a one-way relationship. Okay. Another thing you can have here is, so let's talk about adding some functions here. Let's say this father has some plan for a vacation. And the father says, let's say, let's go on a long ride on my bike. Now you can create an object of type father and call father f dot vacation from here if you are making an object of type father. Huh. So that's the question. Can we do it for rich father also? Yes, right? Yeah. Because rich father is inheriting everything from father. Right. So this vacation function, it exists for rich father also. So it should be f dot vacation, right? Okay. So rich father says, let's go for a ride on Honda. But don't you think the idea of a vacation for a rich father might be different from that of a father? Right? His behavior might be slightly different. So what do we do now? I'm going to add one more exactly same function here called vacation. And let's get this line from here. Yes, you're right. Right. So now rich father says, we won't go on a ride on Honda. We'll fly in our private jet. Now look at these two functions, right? Vacation, it's in the superclass and it's in the subclass. Now you shouldn't be confused. You see, it's not the same as function overloading that we saw before. What happened in function overloading? You had a function with the same name, but your arguments were different. If you look at in this case, it's exactly the same function, same signature, same return type. Nothing is different here. Right? So it's a slightly different concept. It's called method overriding or function overriding. I'll just we put here. It is called overriding. But now the question is, when rich father calls vacation, which version should be called? Which one? The jet one or the bike one? The jet one, right? Which is more specific. Is that clear? Logically, that should happen, right? So let's check. So it says, let's go fly in Honda Jet. So you can have exactly the same function in your superclass, your parent class, or your base class. and in your subclass, the child class or the derived class. Right? And if there is a function with the same name, when the derived class calls it, the more specific one will be called. In case you do not write this function, then the one from the superclass will be called. Okay. Okay, now let's take a look at this code. So again, we have a class father. It's a slightly extended version of the same code. Father has some attributes: name, age, job, bike, salary, a constructor, and a default constructor, and then a function which prints out all the details of the father. And then you have a rich father, which extends father as previously. He has few more things: his own car, some net worth, and a mansion, a constructor of its own, and a method again to print all the things about the rich father. That's all. Then you can create an object of type rich father and print all these details. Okay, do you see any problem with this code? Not syntactically, but an inspiration with which we started the idea of inheritance. It is too lengthy, right? Can we do something about this? Any ideas? So we are already printing a few things here, right? Name, age, job, bike, salary. Exactly same lines. We are using them in the print details in the rich father class. So what can we do about it? Can we reuse something here? We can take rich father. Okay. That's the common sentence. Right. So somehow we need to separate out the common thing. And we know what are the common lines. Right. These are the common lines. 1, 2, 3, 4, 5. Right. These 5 things are essentially printing the same information: name, age, job, bike, salary. And here also, if you look at these 5 lines, exactly the same thing: name, age, job, bike, salary. Wouldn't it be great that instead of writing all these 5 lines here, I could just call this function directly? So can I call a function of the superclass from the subclass? That's what we are asking. Okay, so what if I take these 5 lines out, right? And I'll say print details. What will happen? Something wrong? Let's try to see. Didn't expect that. Oh, what happened? What happened? There is an exception in the threadme and it says there is a stack overflow error. When does that error come? Recursion, right? When you exceed the recursion depth. And that's what's happening, right? You are calling print details inside print details. You're calling exactly the same function, right? So it just goes into an infinite loop. We don't want that. What do you want is you want to call the print details function, but not this one, the one from the superclass, right? You want to call this one. So you can specify that with the keyword super here. Right. So what you are saying, call the print details function, but call it from my superclass. I'll give you a minute. Any questions about this? Okay. So the idea is, let's say you have the same function with the same name in your base class, in your superclass, and in your subclass. And let's say for some reason you want to call a version of the function from the superclass, then you can use a super keyword. So let me elaborate it on further. So let's say I have a function here called some function which does something, right? Any function. It's only there in the superclass. Now, if I write func here, what will happen? Let's say anywhere I write in any function, it will call the one from the superclass. The problem is, what if I create one more function func in this subclass? Right? Then it will call the subclasses function as we discussed. But in case you want to call a version from the superclass specifically, you use the super keyword. So I'm again repeating. If you have a function with the same name in the superclass and in the subclass, if you call that function from the subclass's object or from the subclass, it will call its own version. But if you don't want to do that, want to call the one from the superclass, use the super keyword, super dot. We'll look at more examples here. Okay, any questions? Let's check that. Okay, previously there was recursion error because it was like this, right? So you have a print details function in the subclass and you are saying print details again. It calls the same function from the subclass and keeps on calling. So there's an endless recursion. Now there is no recursion because when you say super.print details, you are calling a different print details function, not the same one. Right? And there is no recursive call in that function. Okay. So let's come back to this code and see some more uses of super. I'm just going to make it smaller. Okay. So we have discussed that usually it's not a good idea to initialize your variables directly here. It's always a good idea to do it with the help of constructors. Right. So when it comes to constructors, it becomes a little bit involved. So let's try to do that. I'm going to put a constructor here for the class father, which is going to set this. And same thing here. F dot byte. Okay. What do you think will be printed now? So you see, we are creating an object of rich father. So when you create an object of rich father, you are calling the constructor of the rich father, which is going to set this private jet to Honda jet. But what happens to bike? You are creating an object of the derived class or the subclass, calling the constructor of the subclass. You are not calling the constructor of the base class here. So how is the value of bike going to be set? Do you think it will be set or it will be null? Okay. So you create an object of rich father, right? You are calling the constructor of the rich father here. That's how the object gets constructed. It goes, calls the default constructor, sets the private attribute, set the private jet attribute to be Honda jet. Right. So if you look at the private jet, it will be Honda jet. But what about bike? How is that initialized? Will that be initialized or not? Maybe no. Shouldn't be the first one. Shouldn't be? The first class, father class. Bike is there in the father class, and you are initializing it in the constructor of the father class. But you are calling the constructor of only the rich father here. Error? Null? And any other thing that you think might happen? Let's check. No error, and it correctly initializes bike as Honda. So what do you think is going on here? Java is smart enough? One by one, yes. Cherry, go. Of the right, the constructor of the superclass is getting called automatically. Right? So what is happening here is when you call the constructor of your derived class, it comes here, and before doing anything here, it automatically calls the constructor of the base class. If you want to see a proof for that, how can we do that? You can put a line here, and let's check how these constructor calls are happening. So let me say superclass constructor, or you can say father's constructor. So whenever the constructor for the father class is called, you'll see this line printed. Whenever the constructor for rich father is called, you will see this line printed. And let's check how the calls are being done. Sami Gole, not doing Python. You see what's happening? First, the constructor for father is called, then the constructor for rich father is called. Even when you are creating an object only for rich father. So it takes care to call the constructor of the base class. And how that happens is, so there is a hidden line here which you do not see, the compiler places it, which goes like this. So you can also explicitly write it. So if you write super followed by these braces, it means you are calling a constructor of the super class. So tomorrow we'll see how do we work with parameterized constructors. Okay, we are going a bit slow. So about October 3rd, October 2nd is a holiday, right? October 3rd, we'll have the first feedback activities on your projects. I hope everyone has filled the form. So I allocate every team like 3 to 4 reviewers. Amongst yourself, we'll have 2 sessions. So per team, there will be 3 to 4 reviewers. Right? A team is presenting and there will be 3 to 4 reviewers who will be reviewing your work. And we'll have to do it again. So what the idea is, you're going to get a lot of feedback and some of it can be really bad. So we have done this activity in the social computing course. I collected all the feedbacks from the students about the teams. And there was some feedback I couldn't share with the teams because I was sure it will discourage them. So the point is you will have to be slightly thick-skinned to take the feedback. Sometimes it can be really difficult. So when I got feedback for a paper almost, it was midway in my PhD in the 3rd year. So submitted a paper and the reviews I got, they were almost like soul crushing. So there was a lady actually whose paper I referred, and she was a female. Her name was pretty much like me, so you couldn't make out the letters from the name. So I wrote her FE in the paper, and somehow she was the one who reviewed my paper, and she was really upset about it. There were other mistakes in the paper, but she crushed the paper like anything, rejecting it very badly. I packed my bags in the 3rd year and I went back home. I don't want to do a PhD anymore. Told my advisor I'm quitting. Then relaxed at home for some time, started doing some yoga meditation. Came to my courses, worked on all of those reviews again, submitted the same paper to the same conference after a year, with one more paper, and then both of them were accepted. So it was a hard learned lesson for me. That feedback is there not to discourage you. You can work on that feedback, make your project even better. So that is about how to take feedback, but you should be a bit gentle in giving the feedback also. So as an example, don't say what a bad project it is. You should give out certain reasons to whose projects you are reviewing. So a few examples here. So we'll have it for 5 marks. So take a look at this. So instead of saying to your friends your presentation is so boring, right, so give some constructive criticism and some feedback to improve. So you can tell them, maybe put a few visuals, maybe tell a story to make it more interesting. Another example, obviously generated by ChatGPT, not me. Right, but the idea is we can learn from here. right? So that's how you give feedback. Uh, what we want is right now your project should be conceptually clear to you. You should have an idea of what you are going to do. You should have a UML diagram ready for your project until and unless you have a very strong reason for why you don't need a UML diagram. Right? And I think we are midway in the semester. So you can show some code also if you have written some. Preferably it should be there, but you see, your reviewers will be better judge, I think, according to the pace at which the course is going. So I'll share these slides with you. So these are few points on which you can give the reviews. Is the overall idea understandable? Is it logically presented? How much have they explored their UML diagram? Are you covering the principles of object oriented programming? Relationships between the classes, which they are going to show you with the UML diagram. And any kind of creativity and the exploration that the team has placed it. What I would want each reviewer is to give a common point to the entire team. So let's say out of 5, you grade the whole team. But if you think that one particular person or not from that, you can write that in format. That will be here. So what will be given to them is the overall review that you provide, the subjective, the written. Any questions about this? Say, there are some teams here. There are some teams here. So we'll divide the teams in two parts. Some teams here, some teams here. So what we'll do is, for the first half an hour, this side is going to present. So let's say these 4 are in one team. So they are presenting and we'll have 4 reviewers reviewing there. Got the idea? And the reviewers will not be from the same team. So that you get to see each other's projects. Any other questions you have about this? Right now, you should just actually, we have you present them for now. That will say that I'm going to then we feel that it's we are going to change on. I'm thinking, can I cover like one more thing here quickly? If all of you are up. No? Okay. I forgot one thing. I should remove not this, not this, this.